So welcome to our class today. I'm going to show you how to solve questions like this. Question 7a to 7c. We are asked, it's a trigonometric question from Goldman. The test we call Goldman, I believe some of you must have seen it. We are asked to show that 1 plus sine 2a is equals to, open brackets, cos a plus sine a bracket close all squared, and derive similar result for 1 minus sine 2a. So let's go. So first of all, we need to recognize what sine 2a is. Sine 2a from compound formula, sine 2a is something as 2 sine a cos a. That's the value of sine 2a. Then from trigonometry identity, 1 is equivalent to cos square a plus sine square a. That's the value of 1. So we are asked to prove that 1 plus sine 2a is equals to cos a plus sine a all squared. So let's try to prove this now. In place of 1, I will replace it with cos square a plus sine square a. In place of sine 2a, I will replace it with 2 sine a cos a. Let's see what we have if we should do that. That implies cos square a plus sine square a. That's the place of 1. In place of sine 2a, I'm having 2 sine a cos a. So I can arrange this expression in this form by writing it as cos square a plus 2 sine a cos a plus sine square a. So this is now a trigonometric function. What can we multiply to have 1? If we add, we have 2. The factor is 1 and 1. So I will simplify 2 sine a cos a as sine a cos a plus sine a cos a. So let's do that. I'm going to have cos square a plus sine a cos a plus sine a cos a plus sine square a. So let's bracket the first 2 and also bracket the last 2. If we bracket the first 2, we're going to have cos square a plus sine a cos a. Let's also bracket the last 2. We're going to have sine a cos a plus sine square a. So what is common from the first bracket? You can see cos a is a common factor. Let's bring it out. I'm going to have cos a as a common factor. What will be left inside? I'm having cos a plus sine a plus, let's factorize what is common from the second bracket, which is sine a. I'm having sine a into cos a plus sine a. Please note, anytime you factorize, the 2 brackets must be the same. So you can see we have the 2 brackets at the same numbers and variables. So let's take the 2 brackets as 1, which is cos a plus sine a. And let's take those outside the brackets, cos a plus sine a. So this can also be written as, since both of them are the same, I can also write it as open brackets cos a plus sine a all squared. So we have successfully proved the identity. So let's go to the same question. It says derive a similar result for 1 minus sine 2a. Let's do that. Similar result for 1 minus sine 2a. So this time we're having 1 minus sine 2a. What result are we going to have in this case? So the same variable, in place of 1, I'm having cos square a plus sine square a. In place of sine 2a, I'm having 2 sine a cos a. So I can rearrange this by writing this as cos square a minus 2 sine a cos a, then plus sine square a. The same quadratic factor, what can we multiply to have 1? If we add, we have minus 2. The factor is minus 1 and minus 1. So I'm going to have this as cos square A minus sine A cos A minus sine A cos A plus sine square A. So similar process, let's bracket the first two. I bracket the first two, I'm going to have open bracket cos square A minus sine A cos A, and also the last two, sine A cos A minus sine square A. So let's factorize what is common from the first bracket. Cos A is a common factor. Let's bring it out. So I'm left with what here? Cos A minus sine A. Let's also factorize the common factor from the second bracket, which is sine A. I'm having sine A into cos A minus sine A. Like I said previously, anytime you factorize, the two brackets must be the same. So let's take two brackets as one and also take those outside. Which is outside? Cos A minus sine A. So I'm going to have the bracket now, cos A minus sine A, and those brackets outside, cos A minus sine A. So you can see, since the two variables is the same, our result of 1 minus sine 2A can now be written as cos A minus sine A all raised to power 2. This is now the solution for 1 minus sine 2A. So by doing this, we have answered question 7A. Question 7B say, hence show that 1 plus 2 sine A and 1 minus 2 sine A is equals to that. So let's substitute the value of 1 plus 2 sine A and the value of 1 minus 2 sine A into the square root. Let's see what we have. So we're asked to prove that square root of 1 plus 2 sine A and 1 minus 2 sine A is equals to 1 plus tan A over 1 minus tan A. So we have gotten an expression before, let's recall, but 1 plus sine 2A is what we got. We got that as cos A plus sine A all squared, and also 1 minus sine 2A was what? Was cos A minus sine A all squared. So let's substitute them in their respective places. We're going to have the square root of cos A plus sine A all squared over cos A minus sine A all squared. So as you know, I can rewrite this as square root cos A plus sine A over cos A minus sine A all squared. I will group the two square as a single square according to the principles of indices. So we are group mean the square and the two will leave. So we are left with cos A plus sine A over cos A minus sine A. So to achieve our results, of 1 plus tan A over 1 minus tan A, I will say divide both sides, let's divide through by cos A. If we divide through by cos, what are we having? Cos A over cos A plus sine A over cos A over cos A over cos A minus sine A over cos A. So I can divide through in this form. Cos A will cancel cos A, cos A will cancel cos A. What are we left with? We are left with 1 plus sine A over cos A over 1 minus sine A over cos A. But we should recall that tan A is simply sine A over cos A. So anytime I see sine A over cos A, I will replace it with tan A. So this expression becomes 1 plus tan A over 1 minus tan A. So this is the quantity of the equation we need. So we are able to answer question 7b. But that is not all. We are asked that if sine 2a is 5 over 13, so you should find the value of tan A. If sine 2a is 5 over 13, so you find the value of tan A. So it's simple. Let's write back the whole expression for this. Let's see what we have. We are given that square root of 1 plus sine 2a over 1 minus sine 2a is equals to 1 plus tan A over 1 minus tan A. And we are told that sine 2a from the question is simply 5 over 13. Then our tan A becomes the question mark. So that means if I see sine 2a, I will substitute 5 over 13 in that expression. So what are we having if we do that? We're having square root of 1 plus 5 over 13 over 1 minus 5 over 13 is equals to 1 plus tan A over 1 minus tan A. We are looking for the value of tan A. So if I simplify by taking LCM in the square root, I'm going to have root 13 plus 5 over 13. It will give us 13 minus 5 over 13 is equals to 1 plus tan A over 1 minus tan A. So we agree with me, 13 can remove 13. So what are we left with in the numerator? We are left with 18. Denominator, we are left with 8. So let's do that. I'm having the square root of 18 over 8 equals to 1 plus tan A over 1 minus tan A. So what are we do from here? We can start to cancel out if we choose to do so using 2 here 9, 2 here is 4. And what is square root of 9? That is 3. Square root of 4, that is 2. So the whole of this expression is equal to 3 over 2. So I will just simply cross multiply. I'm having 3 into 1 minus tan A is equals to 2 into 1 plus tan A. So if I open the brackets, I'm having 3 here minus 3 tan A. If I put the bracket, I'm having 2 plus 2 tan A. So to find tan A, I will simply collect like terms. I'm having 3 minus 2 is equals to 2 tan A plus 3 tan A. If I sum up, I'm having 5 tan A from the right hand side equals to 1 from the left hand side. Therefore, my tan A is simply 1 over 5. That is the solution to the question. So that will take us to question C. So using the result in A shows that sine A is equals to 1 over 2 square root of 1 plus 2 sine A minus 1 over minus square root of 1 minus 2 sine A. We have to use the result from question A. Let's see how we achieve that. So we are asked to prove that sine A is equals to 1 over 2 into square root of 1 plus sine 2A minus square root of 1 minus sine 2A from the results in A. So how do we achieve these results? So let's see what's the value of what they gave us from A. From A, we are told that 1 plus sine 2A, we got cos A plus sine A all squared, and 1 minus sine 2A, we got cos A minus sine A all squared. So what happened if I should make cos A plus sine A the subject formula? Let's call this equation 1 and equation 2. So from 1, my cos A plus sine A give me the square root of 1 plus sine 2A. Similarly, from 2, we have cos A minus sine A equals the square root of 1 minus sine 2A. So we are having, okay, so let's call this equation 3 and let's call this equation 4. So let me bring equation 3 to this page. We're having cos A minus sine A for the square root of 1 plus sine 2A. This is equation 3. So how do we use this to achieve the result we are asked to prove? How are we to achieve the result we are asked to prove, which is sine A is equals to 1 over 2 square root of 1 plus sine 2A minus square root of 1 minus sine 2A. So how do we get sine A from this expression? How do we get sine A from this expression? So to do so, I will subtract equation 4 from 3. That means we're having equation 3 minus equation 4. So let's do that. If I'm going to do that, I'm going to have sine A plus cos A, which is equation 3, minus equation 4, cos A minus sine A. For the left hand side, let's also do the same thing to the right hand side. We're having the square root of 1 plus sine 2A minus the square root of 1 minus sine 2A. So let's allow the minus sign to go through the brackets. I'm going to have cos A plus sine A. What are we having? Minus cos A plus sine A minus cos A plus sine A equals the square root of 1 plus sine 2A minus square root of 1 minus sine 2A. So you agree with me? Minus cos A plus cos A will give us 0. If I add this 2 sine A, that will give us 2 sine A square root of 1 plus sine 2A minus square root 1 minus sine 2A. So let's make sine A the subject formula. So my sine A now will give me 1 over 2 into square root of 1 plus sine 2A minus 1 minus sine 2A. So this is the equation the question demanded. We have achieved that also. So viewers, this is what you do for me. You use this application now to solve the next question. Say if sine 2A is 1 over 2, find the possible values of sine A in short form using the information given. When you solve, post the answer on the comment section. This is Time of Africa. If you like what you are watching, subscribe, like, and share. See you in our next class. And thank you for your support.